Question 1, kinematics. Before we start to solve this problem, let's just start with a short aide-memoire. Here's a picture which shows you a displacement vector r. To get velocity from displacement, we differentiate with respect to t. The velocity is the gradient of the displacement time graph. To get the acceleration from the velocity, we differentiate again. The acceleration is the gradient of the velocity time graph. To go in the reverse direction, we would integrate. From acceleration, we integrate it to get velocity. Velocity, we integrate to get displacement. On the right-hand side, we see the dot notation, where r dot means the displacement differentiated with respect to t once, and r double dot means the displacement differentiated with respect to t twice. This pattern will allow us to solve all problems with two-dimensional variable acceleration. We're told here that the velocity at time t is given by this expression, so we're going to rewrite that in the r dot format. We've got to find the magnitude of the acceleration when t equals 1. So to go from velocity, to go from r dot to acceleration, r double dot, we're going to differentiate. So we get r double dot equals 6t, which is the derivative of 3t squared minus 1, I, plus 4 minus 2t. That's the derivative of 4t minus t squared in the j direction. We substitute t equals 1 and we get a equal to 6i plus 2j. To calculate the magnitude, it's just Pythagoras, the square root of 6 squared plus 2 squared, so it's the square root of 40. Now we need to work out the position vector of p when t equals 3. Given that at t equals 0, the position vector is I. So again, we start with our expression for r dot. So to get r, we integrate r dot. We do it component-wise to get t cubed minus ti plus 2t squared minus t cubed over 3j plus a constant of integration c. The c will be a vector. When t equals 0, r equals I. We substitute r equals I in the left-hand side, we get I. We substitute t equals 0 in the right-hand side, we get c. And so c equals I. We substitute this back into the expression to find that r is t cubed minus t plus 1i plus 2t squared minus t cubed over 3j. To find the position vector of p when t equals 3, we simply substitute 3 into this expression to find r equals 25i plus 9j.